All right, let's put everything together in this HVAC feedback loop. So we have occupancy, raw CO2, HVAC fan speed, and CO2 dilution. 4 columns, 1 feedback loop, where each value depends on the one before it. In this video, there are 4 critical things to keep in mind. Occupancy follows a daily rhythm. Raw CO2 is defined as 450 parts per million plus occupancy multiplied by an average of 25 parts per million per person. Number 3, HVAC fan wraps up between 20% and 100% based on the CO2 levels. Actual CO2 is equal to the raw CO2 minus the HVAC dilution. This 4-panel chart tells the story. Basically, people arrive, CO2 rises, the HVAC system spins up, CO2 drops. People leave, CO2 falls, the HVAC system slows down and eventually gets to equilibrium. The gap between raw CO2 and actual CO2 is the HVAC system doing its job. Systems are not chaos and they're not silos, and your simulation should model the feedback. Now let's get into the YAML. All right. Wrong YAML. Right, this one. So here, this is where we derive our columns. Here we're saying that CO2 raw parts per million is equal to 450 parts per million, occupancy times 25 parts per million. Then we add some random noise. Fan speed depends on the raw CO2 readings. CO2 parts per million depends on HVAC fan speed percentage. I won't go into too much details, but I will leave a link to our docs page where we go deep into details about all the intricacies and all the explanation that you'll need to fully understand this. Okay, let's run this. Great. Okay, so this is the chart that we generated before. As you can see, they kind of all look alike, but that's expected because, they all depend on each other. And this is what I'm talking about. The orange line is a raw reading, and the red line is the actual reading with the HVAC doing its job. All right. In conclusion, derived columns can reference other derived columns within the Odibi system. Systems are chains, not silos, and again, the simulation should model the feedback, not ignore it. Thank you.